Hello everyone. This is continuation of context-free grammar that we are learning. So in this, you will be given a language and you have to write the production rules for the given language. So there is no finite automata provided. Instead, there is a statement which is provided or a language which is provided, and you have to identify the grammar for it. So let's start with the first one. Strings having any number of A's over input A comma B. Okay, let's start this. Strings having any number of A's. If you were to do this using regular expression, your expression would have been something like this. So RE, when you write A star, it means you are generating a language. Because it is asterisk, you will write epsilon, then string of length 1, length 2, length 3, and so on. So this is the language that will be generated. This is a string which consists of any number of A's. The same thing when you do it using grammar. This is how you will write the production rule. You have your starting symbol S. The first one, I'm going to write it as S derives epsilon because I want to generate string of length 0. Then I want to repeat the number of A's. So this is how I'll write the next production rule. S derives AS. So this S can be repeatedly be used. You can use this S again and again to generate string of length, any number of length. For example, if I want to generate, let's say I want to generate this string of 3 A's. So I will start with the production rule S. This is the production I'll use, AS. This S, next time I'm going to replace it again with AS using this production rule. This S, I will again replace it with triple AS. So I have got the string that I desire. I will now end this. So I have a production rule epsilon, which I can use to terminate the generation of the string. So this is how my string of length 3 has been derived using the production rules. So your final production rule will be stated like this. S derives AS slash epsilon. This is the required CFG. Let's read the second question. Strings having any number of A's over A's or B's over input A comma B. So this is any number of A's or B's. Okay, so again I'll teach you using regular expression first. When you want any number of A's or B's, this is how you write it. A's or B's, and because it is any number, you will show it using asterisk. So the same thing can be written as, similar to previous example, this is the required grammar to generate any number of A's as I showed you in the previous example. This is the production rule for generating any number of A's. Similarly, if you want to generate any number of B's, this is how you will write it to generate any number of B's. And when you want to terminate or end the string, you have epsilon because you have asterisk here. So this is the required production rule for any number of A's, any number of B's. If you want, you can take an example to generate a string, let's say BAA. So for this, you will begin with S, then S, because your string begins with B, I will select the production rule BS. So you also have to show using which production rule have you generated this. So using BS. Now this S, now I want A next. So this I will replace with AS. This is using the production rule S derives AS. So I have B, I have A, now I want to generate one more A. So again, I'll use the same rule, replace S by AS. I have got BAA, now I want to terminate this. So I'm going to use this production rule. BAA, using the rule S gives epsilon. This is how I have generated the string BAA using starting symbol S. Let's move on to the third example. Strings having at least two A's over input A, B. At least two A's. So again, in terms of regular expression, when you want to show at least two A's, this is how you will show. Any string that you generate should have at least two A's. So before you can have any combination of A's and B's. In between I can have any combination, and at the end also I can have any combination of A's and B's. This I'm going to replace it using CFG. So I'll replace this using, let's say, letter A. I'll keep small a as it is. This is again letter A, small a is as it is, and again letter A. So if you observe all A plus B closure, I have replaced it using capital A. So this A plus B closure, what does it mean? It means any combination of A's and any combination of B's. And you know we've done this already before for any combination of A's and B's. So I'll repeat the same thing here. This is AA, BA, because any combination of B's, and to terminate I have epsilon. So this is the required CFG. If you were to show this using 4-tuple notation, your variables are S and A. Your terminals are small case letters, which is only small a. Starting symbol is S, and your production rule. These two are your production rules. Thank you. And next, after that, there is one more. Strings having equal number of A's and B's. Equal number. So equal number means if you have 3 A's, you should have 3 B's. Similar to that. So this can also be stated as L is equal to A raised to N, B raised to N. So this is nothing but A raised to N, B raised to N. That means if N is 1, I will get 1A and 1B. If N is 2, I will get 2 A's and 2 B's. Equal number of A's and B's always. So let's see how to write the grammar for it. Let's move straight away to the grammar now. Equal number of A's and B's. So if my string is starting with A, I will have B at the end. So if I have 1A here, I will have 1B here. If my string, since I have written here that the sequence is A raised to N, B raised to N, that means I will always get A followed by B. A followed by B. So this will be ASB. Then if you want to repeat, you can always repeat it using ASB. And when you want to terminate, you will terminate it using epsilon. For example, if I want to generate 2 A's and 2 B's, I will start with S, then I'll replace S with A, S, B. I want one more A, so I will again replace S with A, S, B, and keep this B as it is. And this S, I will replace it using epsilon. So this is how I'll generate the string. Okay, now let's find out what if A raised to N, B raised to N was not required. That means what if only A's followed by B's is not required? You just want equal number of A's and B's. That means I can have B followed by A, or I can have BA, BA, still they are equal in number. So there is no condition that A should always follow, A should be followed by B, but you can have any combination. I can have a string starting with B, ending with A, starting with A, ending with B. So any combination is fine. If that is the case, then your production rule will be in this way. If your string begins with A, it should end with 1B. If your string begins with B, it should end with 1A. Then, in between also, if you observe, beginning with B, ending with A, but in between if you see, I have AB also. I can have AB combination also. So this SS, this is SS. This is another combination, S and S. That means you can have two joining or concatenation of starting symbol SS and finally epsilon. So if I want to generate the string BA, this is how I'll start. Start with S. You want B first, so I'll select this B, S, A. Then I want A, so I'll replace this with ASB, and then I can replace this with epsilon, so I'll get BA, BA. The same thing I can also generate using SS.